Hey, what's going on YouTube? It's time for a day 13 of Advent of Code. We're getting ready here to get started. We've got 4 minutes and 42 seconds left on the clock. So as we get started here, I've been working on visualizing day 12. And so I figured I'd share that with everybody here. If I just run this, what you have here is taking that grid from day 12 with all of the letters, and this visualizes the algorithm that I wrote to walk through the grid and kind of build everything based on their grouping. So the approach I took was, starting at 0, 0, picking that letter, crawling the grid, and then moving on to the next, position, and then tracking the map of visited points. And so we just kind of repeated that process all the way to the end until we had our groupings. Each color here is associated with the letter of the grouping. So I created a map of basically letter to RGBA color. I actually used an LLM to generate that, which it did a pretty good job making them distinct enough. And so you can kind of see how everything maps out here in the grid and kind of colors it as approach. And then once these groupings were collected, we went back and calculated the perimeter, the area, and the size. So we'll just kind of run this here all the way to the end. Pretty neat visualization. There's a couple more in, I think, like day 10 and day 9 I may end up visualizing as well. But day 12 was pretty straightforward based on the way we approached the problem. So I wanted to go ahead and share with everybody here what that looks like, and just kind of neat little visualization. So I thought it was pretty cool. So I'll share with everybody, and hopefully you find it interesting. The code to build this is in the library that I have, the Git repository. Using this grid concept. I was calling it matrix, but I refactored it to grid. You can visualize that grid pretty easily, and then kind of step through and color cells in the code. So that's kind of what this is here. That's just something I wanted to share. I did refactor a couple of things in this, and kind of want to try something new with our tests today. So I'm just going to have them continually running in the background as we code, and then we'll kind of just see how they complete as we complete the challenge here. Thanks for joining. Thanks for hanging out. Find this kind of thing interesting, please like and subscribe. Not really trying to build a following here per se, but I do plan to do more things in the future here. I have some pretty interesting projects that I'm working on regarding like LLMs, Golang, using a LangChain implementation of Golang. And then I mentioned it before, but doing some chess battling between Anthropic and OpenAI and some of the other LLMs out there. We can kind of dive into that in a later video, but I want to, once I get through Advent of Code, hopefully make it all the way through. But if, wherever I end up stopping, once I'm, done, we'll transition to some of the other content, fun stuff. It's interesting. This is starting to look like a 1 and a 0, maybe a 1 and an 8, some sort of number representation over here. I don't know if that's quite what it is, but it's kind of interesting that you've got some reindeer, looks like a bus, some other Christmas tree, some other things here. So 16 seconds. All right, let's dive in. Day 13, claw contraption. Next up, the lobby of a resort on a tropical island. The historian takes a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machine. The claw machine here are a little unusual. Instead of joysticks or direction buttons to control the claw, these machines have two buttons labeled A and B. Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and specific amount forward along the y-axis. Each time that button is pressed, each machine contains one prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axes. You wonder what is the smallest number of tokens you would have to spend to win as many prizes as possible. You assemble a list of every machine button behavior and prize location, your puzzle input. For example, button A, x plus 94, y plus 34, button B, x plus 22, y plus 67, and the prize is at this location. Okay. The list describes the button configuration and prize location of 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along the x-axis and 34 units along the y-axis. Pushing the B button would move the claw 22 units along the x-axis and 67 units along the y-axis. The prize is located here. This means that from the claw's initial position, it would need to move exactly this many units along the x-axis and exactly this along the y-axis to be perfectly aligned with the prize in this machine. The cheapest way to win the prize is by pushing A button 80 times and the B button 40 times. This would line up the claw along the x-axis and along the y-axis because doing this would cost 80 times 3 tokens for the A presses and 40 times 1 for the B presses, total of 280 tokens. For the second and fourth claw machine, there is no combination of A and B presses that will ever win a prize. Okay. For the third claw machine, the cheapest way to win the prize is by pushing the A button this many times. Doing this would cost a total of 200. So the most prizes you could possibly win is 2. The minimum token you would have to spend to win all 2 prizes is 480. You estimate that each button would need to be pressed no more than 100 times to win a prize. How else would someone be expected to play? Each button would need to be pressed no more. Okay, so that's estimated, but no more than 100 times. So we know that if we hit a particular button over 100 times, we've already gone too far. Figure out how to win as many prizes as possible. What is the fewest tokens you would have to spend to win all the prizes? Right, okay. So we'll go with this and we'll update our test. This is 480. And then let's get our input, which is this. I will put this here. Okay, so we need to regex this. This isn't really, well, we need to split this. We can split the file first by double hard returns, and that'll give us the block for each section. And then we can kind of parse line A and strip out line B, strip out and then prize to determine where the prize is. So let's just do that real quick. We'll just get that taken care of. And so let's just create a struct. We'll call it number of tokens each machine. We'll just call it machine. Why not? and that's going to have our, we'll call it A, which is just going to be a slice of int. And we'll call it B, which will be our slice of int. And then our prize, which will be slice of int. Yeah. So that's what we're going to return for each of these. We'll just go ahead and grab that, and that'll be our XY, 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 etc. Maybe instead we'll call this PA, PB, or PR. We'll use the same names, PY. We'll just go with int. Yeah, we'll just do this instead. This will make the code a little bit cleaner. Yeah. And then to actually parse this, we're not going to use the grid. Instead, we're going to say bytes.split, and our input is this, and our output is going to be /n/n/n. So and so now we've got we can and we'll just do that. We'll do strings here, and we'll just turn this into a string. It'll be easier. And then we should see we'll add an extra line there. Yeah, okay, cool. So then we'll call this lines, and we'll do strings dot split, and we'll take in our section, and we'll take in this will be a /hard return, and then we know that line sub 0 is going to be our first set of input, which is going to be this. And so we'll use a regex here. I'll just put up here var re button equal regex p dot must compile, and the must compile will be our regex here. And so we want let's see here. Let me look at this input again. Just kind of thinking about, I could take a couple different approaches here. I think I'll just strip. So no. I can do the regex. It's fine. We'll do the regex. Yeah, we'll do the regex. Let me grab the text here. So I should be able to write a regex for this. So it should be something like button space some word colon space plus a special character /d plus comma space then we create our capture groups. And then we can do something like RE button dot find all string submatch, and we can pass in lines sub 0. What's the int for though? Returns a slice of all successful matches of the expression as defined by. And then we can say all right, I want to run this more than what it's running right now. I just want to be able to like run it as I want to. And I don't understand the number here. Yeah, 6923. Okay. Which is what I want. So then I just need to do no. Find string submatch. So I should only have one of them, right? So we can make this a little less complicated of a structure. Yeah. Okay. So we could say AX, AY. Yeah, so we gotta do this, which is string convert dot A to I. And we need to pass in match sub 1. And then this is going to be sub 2 because subindex of 1 is not what we want. And then we want to repeat this, but for the next line, and this will be BX. I don't know why I call this AB, it's AY. And then this is BY. So that should take care of my first two buttons. And then the last case here is the input here, which is the prize. So we can again kind of do the same thing, and we can do var RE prize. You know, we could have probably approached this with like a different way of like eliminating things that we didn't need, but I think this is fine. We can actually simplify this a little bit and just be a little more explicit with the x equals let me get rid of that. Yeah. And we'll put that there. And then we want to capture these. Yeah, I think that's fine. And we'll call this line 2. And this is going to be RE prize. Find string submatch. And this will be what is it? Prize PA, we'll call PA because I think it's just to kind of stick with the derivative that we're already in. And that'll be match sub 1. And then this is match. That's not right. PX and PY. Match sub 2. Maybe we can actually call this button A. It doesn't matter. We'll be fine. And then we want to, now for each of these, we're going to call these and we'll do machines equal to append machines machine, and this should be AX, AX, AY, AY, BX, BX, BY, BY, PX, PX, and then PY, PY. All right, cool. So now we've got all of our machines. Why do you not like me? Oh, because I needed to do this and this. Right. So we're going to go back to watching our test now. Right. So we've got, we can get rid of this. Not that, this. We can get rid of this. And we can get rid of this. And then we could, if we want, we could say yep, so those are all of our machines. AX 94, AY 84, 54. We can look at that. That looks right. Okay, cool. So we've got that down. So now the question is, we have to get to this destination on each machine. And so the question is, the cheapest way to win the prize is by pushing the button 80 times and the B button 40 times. So how do we do this? So we could iterate, and we know that we're always going. Let me double check our puzzle input here, but as far as I can tell, Are there any negatives in here? Did I? Okay, it doesn't look like there's any negatives, so we don't have to worry about like going any other direction than to the right and down, right and down, right and down, right and down. So then the question becomes, how do we determine, I mean, we can just branch it every time, right? And so every time we go down, if we surpass X 8400 and Y 5400, or we surpass pushing the button 100 times, then we know we've gone too far. 200 tokens. Okay, hold on. What's the cost? Pushing the machine's A button would move the claw 94 units. Yes. 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 What's the token cost? How do we score this? What is the... Doing this would cost 80 times 3. For the second and fourth claw machines, there is no combination. For the third claw machine, the cheapest way to win the prize is by pushing the A button 38 times and the B button 86 times. Doing this would cost a total of 200. So the A button, and so it costs 3 tokens to push the A button, or I'm sorry, it costs 3 tokens to push the A button and 1 token to push the B button. Got it. Okay. So now that we have our machines, I mean, what I'm thinking is we just kind of follow the path of each branch and we look at it as we follow it and we determine what the cheapest amount of tokens are to get to our value. And we can go ahead and calculate cost like as we move. And then once we exceed the prize, we just end. So is less than the machine. Call M, just make these a little bit easier. M dot PX. We'll keep it this narrative. Sorry, I prefer R and C, but considering that we're here, and y is less than m.py. And then we will do man, I think we need to do let me think about this for a second. So I don't want to recursively loop through. Or I mean, I do want to recursively loop through. I don't want to just loop through and increment the value each time, because we're going to need to branch each time. And depending on which way is cheaper, that actually gets us to an end result. So if I do it's got to be that. And then we have a function called push, and that function so we'll call it lx ly int, and we'll say if lx yeah, we'll just do that for now. So our limit is always going to be m dot px, m dot py. So that's our prize x, prize y. And we know if so if this is going to be a, so this is our p, or we'll say our bx by, although we have a bx and by, but we'll just say button x and button y. That will be 0 and 0 and 0. So this will be m dot ax, m dot ay, m dot ax, m dot ay, sorry, by and bx. And then, so we know our cost is, was it 3 for A and 1 for B, right? Something like that. Let's call it total. And then because we could just calculate the total like as we go, right? I mean, am I missing that? It's as we iterate down, we just calculate the total because we want to just return the first claw machine, the cheapest way to win the prize. So pushing the A button 8 times, B button 40 times. Doing this would cost 80 times 3, 40 times 1. Well, we could just add to the cost every time we go down a particular path, right? So the problem is that this doesn't have the context of the machine. So that needs to happen because we are going to push again, right? I suppose if we pass that, then why are we passing? I guess this would be yeah. So maybe we can eliminate some of these variables. So we just need to know which one is the right one here. And so we don't want to consider that's fine. Score plus equal A. Otherwise, score plus equal B. So what we're saying here is that if A is less than B and A not equal to 0, we're going to plus it by that. Otherwise, we'll just take B. If B is 0, meaning it wasn't found, that's fine anyway. Then score is equal to 0, and we get rid of this. And we set this to this. And then, let's see here. So then we want this same behavior, I think. So meaning we can return A. So we just keep pushing, and then at what point do we return? So instead we will say if bx equal to lx and by equal to ly, return total. If bx greater than lx or by greater than ly, return 0. Otherwise, we go down, and we always are checking to see what the cheaper path is. And we can remove that and remove that. And our default option is always return B, which might be 0. So that way, if we don't find any path here, and so go routine stack succeeded. Oh, that's exciting. Is it just because I didn't have good if or exit conditions? Or is it because I'm just a terrible programmer? Considering this test is taking a really long time, I think I might just be a terrible programmer. Let's just do it this way. Do we actually have the test input in here properly? Yes. What does the actual input look like again? Well, that's a lot. Okay. Yeah. Right. Okay, so the problem is what? So we put in a total of 3 and then a total of 1. I think this actually needs to be total plus 3 and total plus 1 instead of the push here. That way it adds to it every time, whatever our total is. We either add a 3 or a 1 depending on what we're pushing. Okay. Here, let's do one other thing here. See how far we're getting. Sure, I'm not doing something stupid. That's not what I wanted. I mean, it shouldn't take us that long to get 268.01 and 38.10. Like if we're here on this machine, we push the button. I suppose we should make this like a pointer. That would probably be better. We're passing less of those around. Okay. So we push, we get a 3. So we push, we're going immediately to the AX and the AY, the BX and the BY. And we've got a prize X and a prize Y. Those are all accurate. AX, AY. So now we're inside push, and we say if BX equal to LX and BY equal to LY, we return the total. We know we've gone far enough. The button X that we press is MX. Oh, here we go. This is Y right here. Well, I don't know if that was the only problem, but it certainly was a problem. Since we actually don't need to include these as we're pushing, since we're including yeah. And then get rid of these. Yeah, we're gonna run this a little bit faster so we fail quicker. Right. It's a pretty big stack. Way bigger than I'd expect. All right, let's log where we're headed here. Because these are just ints. AX, AY, BX, BY. Be a little crazy, but we're going to do it. We'll go with BX, BY, and total. Should be a pretty large or substantial amount of output here. So what are we getting? Checking 84, 64, 38, 29. 84, 64, 38, 29. Well, we're over on the X. But we're not over on that. So Okay. Um, yeah, I'm still on part one. I try to do recursively, and I think it's just not the right approach here. Um, there are way too many calls taking place, and I am, yes. So, mhm. Yeah, I thought about that using a queue, and then you essentially put your cheapest cost, right? And you go to whatever your cheapest is next, and you only process that one in the queue. Yeah, yeah. I did it last year, um, and that will prevent all of these calls. So that is definitely the answer. Yeah. Priority queue. Yep. So let me think about how I want to implement that. Yeah. Okay. So we can. Trying to think or remember. I implemented one last year, I'm pretty sure. Yeah, not that one. Not that one. Yeah. Here we go. Yeah. Let's get started here. I don't need any of this. This will probably not be a machine though. This will probably be a point. Yeah. Yeah. Yep. So if we do it this way, this will not be a city block. This will be a button push. And so call it do something like that. Right. And so then get rid of this because I'm a terrible programmer. That's awesome, Tim. That's pretty good. I'm struggling with this one, obviously, so it's taking me a minute. So let's see here. Yeah. Yeah, so what I should be able to do here is for each one, so we're starting at 0, 0, total cost 0, and then I can put button A and button B onto the stack, and I can get the one with the less total cost as I pop off each one, and then we can keep doing that, but only if the next button is within range, right? So like if P dot oh, you got typecasted, that's why. Okay. Yeah, so this needs to be yeah. So if P dot so then I could say if P dot yes, so well, I'm not really sure, pedantic, if it could be well, maybe. I don't know. I'd have to look more into it. I honestly haven't used Go heaps in like forever. The last time was last year I did when I did admin code, so I'm not super familiar with it. So it's kind of a it would be interesting to see if we could do something in generics with the heap though, instead of having to do this typecasting, but it's okay. So if AX is greater than M dot PX or AX is greater than M dot PY, we'll do less than we'll put the next thing on the heap, right? It should be P dot total cost plus 3, something like that, right? And then we could do the same thing repeated for the B side. Yeah, I heard it's not that I'm doing this for ranking, but I heard it's particularly more difficult right now with um there's more people trying to solve it just with pure LLMs. I don't know how true that is. So the rankings are a bit more difficult, but I'm sure as the problems scale, you'll have less and less people who are or less and less. The LM is less and less likely to actually complete the problems. So bx is less than the px, and by is less than that. Same thing with ax and ay. Yeah. Interesting. So how do I qualify the lowest possible score then? I guess it's if ax if p dot x equal m dot px and p dot y plus equal p dot total cost to get here. And then really, I mean, this is what a heap per machine. Is that really what we need to do there? Something like that. Yeah, we shouldn't be doing the checking anymore. So what do I need to get rid of here? If AXAY is the same as BXBY, then there could be multiple solutions or no solutions. Heap should only sort by cost, right? Not total cost. You just yeah, okay. So I am doing total cost. Yeah, I think I might be missing a exit condition here. Um, I don't know what that is. What is Chinese remainder theorem? So I have a heap. Okay, I'm traversing the heap. Okay, got it. Is my cost calculation just off? I mean, it's just a 200 tokens. Hmm. Ah, okay, okay. So if we're at 0, we've got 3. AX, X is that. B total cost is that plus 1 for B. BX, BY. If BX less than, yeah, I mean, I don't think I even actually like need this. This is just a, like this should not add. I guess I'm not actually like calculating depth here. I mean, is this like a, I mean, I realized it was in the 5370. What's in, let's go to my test input for a second. We just reduce this down to one problem. $53.70. All right, let's take a look. So if AX is less than M dot PX or AY is less than M dot PY, I mean, if we're equal on both of these, oh, I guess this is the new position. Okay, fair enough. I see what you're saying. Okay. So we're not actually getting to an end and we're continuing to process other things on the heap when we shouldn't, because I'm not allowing that point to finish. Because we're not getting to this condition. Still timing out. So I shouldn't be seeing these. So that means that our condition for exiting is not working. So this should be and as well, not or. Still too long. Oh, like revisiting? No, I don't. That's what I'm missing. So, but I mean, we're always going down and to the right. But I suppose if we get there from like a different button push, we don't really want to. But we could get to that. I guess we could get to that particular point with a cheaper cost. But we should always get to it with the cheapest. Okay. Okay. That's getting somewhere. Right. So value here. Um, that is because I modified my test input to be only 1 to get this to run faster. There we go. Probably don't want to log all that. Well, do we need the cost in there? I mean, if we're always going for the lowest cost, we should always get to the point, right? In the cheapest way first. I don't think we want cost in there. Let's see. Could be wrong. All right, cool. Part one's done. No, that wasn't painful at all. The first half of this puzzle is complete. All right, part two. Nowhere near where you expected it would be due to a unit conversion error in your measurement. The position of your prize is actually higher on both the X and Y axis. Add this to the machine of your prize after making this change. The example above would now look like this. Yeah, no, I understand that concern, and I think that might be true if we were going in like multiple directions, but you might have something there. There might be an edge case, but I'm thinking through it, and I think we would always pick the cheapest cost first to get there. And even with the more expensive A moves, if they were moving at a larger pace, theoretically we could get there at a cheaper cost, but like I think they would just outpace each other. So I don't think it's necessary, but I could be wrong. So yes, much bigger values. Got it. Cool. Yeah, so how do I want to do this? Let me I mean, I've already been here for this long. So let's let's do this. And then we'll take this block right here. Probably to there actually. Yeah. And we will return What do you mean? 875318. What do you mean? For the sample input? I don't understand. And then we will give that the M. Is the jump always? Yeah, something like that. Is it just me pedantic, or do you just join to save the day every time I'm struggling? Not that mind. Absolutely appreciate it. Like I did just fine yesterday. Actually, I'm going to do this. Yeah. And then we'll do m dot px times equal times equal. I'll just do this the so I mean, do we actually have to calculate? I mean, if we know too many days, too many days. I mean, isn't this just the shortest path to here is just the shortest path to here times, is it not? Hmm. I don't have the solution. Pedantic solved the solution. There's another guy in here, Tim, I think, who also has, I believe, solved it. Oh, for me or for the people in the chat? I mean, there's no policy here. Spoiler away. If you're here, you're hanging out. Yeah, this isn't work. So I'm gonna lock up my entire stream here. What's the sorry, Pedantic, did you put the test output, by the way, for the sample? Yeah, okay. Let me just go. Appreciate that. Hmm. So if we instead what if we made some could we think about this in a way let's look at the input. So if we know could we skip to some degree and just multiply our cost, right? So if we look here, so like what do we do here? So if we add some sort of skip factor, we could get to the end result, but as we get closer, we could, if we do that, we could skip over a node. And if that is a while number. What do you mean by if that is a while number? Sorry, not a math guy. You mean whole number? Yeah, advent of math. Mm-hmm. Mm-hmm. Okay, yeah. Yeah, I don't really. Okay. This is why. Well, anyway. Right. So n times ax plus m times bx. Yeah, I don't understand. Is this just a math problem? Like, we just need to solve it mathematically and not even. Makes me sad, but understood. So you're saying you don't even try the route if this condition isn't true. So, okay. So what am I doing wrong here then, Tim? Like, let's talk the maths here. Hmm. I think yeah, no, that's the problem. But we don't have to. Well, I mean, we're gonna go. What if we did something like No. Mm-mm. Yeah. I'm kind of stuck. I'm gonna be completely honest. Like I need to maybe rework this entire solution. And if it is just trying different maths, I mean, it's a lot of possibilities to check right now with the priority queue, and it. I mean, we can try like doing some sort of like skip factor, but I just don't think that's even a reasonably smart idea. So what is n in your solution then, Tim? N is yeah. I just don't. It's the maths are kind of beyond me. Okay, and so you just instead of you actually checking, you just increment n and m, and you go back and forth with each one until you get close to your answer, and then you do maybe. I mean, we know that there's going to have to be some variation of n and m, or those two numbers being pressed. I see. I see. So that's what the other calculation is. Okay. So you approximate n and you approximate m, or you calculate exactly n and calculate exactly m based on the input. And then you plug that into m equals px minus n times ax. Okay. Gotcha. Okay. So okay. I mean, can we approximate like the location of it? It's just all guesswork at that point. I'm just trying to think if there's another approach where we didn't have to use just maths, but I guess yeah, that's just what it is. Right. So let's talk this through then, Tim. So see if I can do this. Yeah, yeah, not really much of a math guy here. So highest power of the variable is always 1. Let's see here. So I don't understand, is integer division, at least in Python. For my input data, there was only 1 or 0 solution. N is the number of times you press A, and M is the number of times you press B. So okay. So what is M? AX times EX divided by AX times yeah. Help me out here. I'm struggling without you, Tim. So you are all I got. You are my hope and my prayer. Okay. Right. So okay. So this is PX, right? And is this YX or sorry, AY? Is this what you're saying here, that these are true and we have to figure out what N and M is? Is that where we're headed? Okay. So then okay. So what is N? So I still don't have N, right? So okay. Yeah, okay. So I'm with you. And so n is, yeah, 3 times n plus m. Okay. And there we have it. Okay. So I understand. I understand it can be done with maths, and it's getting to the right maths. So we can plug this in. So here we'll do this, and we'll uh, do this, and we'll run our test. Okay. So let's take a look and see what I didn't do right. Um, m equals py minus n times ay. Oh, that's ay. Okay. Divided by I dot py. Okay. Oh, I do. I got this. Okay. Well, appreciate it. I don't feel like I got it, but I appreciate your time, Tim. Thank you. And you have a good night. Py minus n times ax bx. Px times by. Oh, you know what I did do wrong here is this should not be true. Actually, it should be true. Never mind, I take that back. So 1367. I don't understand that yet. bx times by minus py times bx divided by ax times by minus ay times bx. Is negative 96. Well, that's part of our problem. N is right. Hold on, let's go back to our original test. N is 80 times, and N is A. So N is right. This is an example, but M is not. So why is M wrong? M says 96. M should be 40 for B. So why is it not right? I'm going to get rid of my other test for right now. I'm going to stay focused on this. Ah, okay. So that's right. Ah, however, this cannot be fractional. So if this is a fraction by any stretch and not a whole number, then that's why not every machine would qualify machine. I could do, let's make this a little bit more of if so let's do we're going to do I dot ax times n plus I dot bx times m equal to I dot px and this is in Java. What are we doing? If this is true, then we return this. I realize we can check for a fractional number, but let's just try this out real quick. We'll get back to the maths here. Nice. Okay. So what I'm basically doing is saying, give me n and m, and then let's check the maths. And if If in fact we return px and py, then we return the algebra or the value. So what's going on here is that there is, because we're doing integer maths, n and m are probably getting truncated, considering we don't see them as fractional here. And so we could turn all this to floats or verify the maths makes sense. We're just going to go with that because maths aren't my strong suit. But this gives us our answer. So we do the linear algebra, we come up with n, then we come up with m based on what's n, and then we check to see if it's true. If these are fractional, or in this case, let's double check to make sure they equal up to the positions we have, then we return those values. So now if we go back to our test case, okay. So why? It works for part 1, but it's not working here. Um, just see if this is the issue. Verify things make sense. I think we can verify. Okay, so what did I do wrong here? Okay. Ah, let's look at. Of course, these are going to. Yeah, these are going to equal here even, because now we don't just have integers. We've got these floating numbers, so this validation is not going to work. Um, Hmm. Um, oh, wait a second. Hold on. This should be a plus equal, not a times equal. I made the problem that much worse for myself. Okay. Right. All right. There we go. Day 2 complete. Or sorry, day 13 complete. Man. All right. Let's try one other thing here. If I go back to the original here, and we try the non-Dijkstra way or the non-math way. Yeah, never mind. We'll ignore that. Um, let's see if we can clean some of this up. There's no point in doing Dijkstras here. Man, oh man. I think what I want to do is just switch all these to float 64s and then deal with the pain here. Now, I can do a string convert parse float and then $64. And then I think all of this can then just go away. And this becomes back to I dot, I dot, I dot. Double check, make sure that is the answer that I got. Yeah. And then we'll get rid of this. And then we're done. So to recap, man, that was a bit of a struggle bus today, but let's get into the solution. So initially we took an approach of doing a recursive function, stepping through each iteration, and we ended up with some very large call stacks. Did not think that through initially. And instead we shifted to using essentially implementing Dijkstras with a priority queue. That worked for problem one in a pretty reasonable amount of time. But moving on to, increasing our value by a large amount, that was not solvable. And so, at least in a reasonable amount of time, I also goofed by multiplying instead of adding, but let's just move on. So really the answer is this is just a linear algebra math problem. We can solve it by some maths, which we have here, and we can determine what n is based on some values, and then we can determine what m is based on some values, and they should equal to a whole number. And if they don't, then they're, even though they will get you to the solution, there's not a solution to the problem. And so once those were calculated, we were able to validate that by checking to see if n equal to the math of trunk n, which is getting rid of any of the decimal points. And if that's true, then we know we can return those two values and we're done. And so now what was some very complex approaches to handling this issue, we have solved with linear algebra. I guess that's why they call it advent of math. In some cases, sometimes it's a programming problem, sometimes it's not. I know in the past, these are some of the reasons I stopped Advent of Code, because but I guess as a software engineer, you should know maths. I guess I don't know where I would use this in the real world, at least for the work that I do. But I guess maybe that's because I'm not doing UI development, right? So at any rate, that was my long approach and drawn out process to it. But the short of it is, this is the answer. Everything can be described right here to get to that solution. I really big thanks to Tim Whalen. He helped me out quite a bit here. And other than that, it's just parsing. And so I took a regex approach to parsing out and kind of creating those machines with the prizes. Created a struct for those, and then based on that, everything else is pretty straightforward. So, all right, well, that is all for tonight. I appreciate everybody hanging out. I appreciate the back and forth and the conversation. As always, thank you for your time. You all have a good night.